Ice is solid. Solids have definite shapes and volumes. Why can't you walk on water, just like you did on the snow? You can't walk on water because it is a liquid, and liquids do not have definite shapes. However, liquids do have definite volumes. Liquids also take up the shape of the container they are in. Watch out for those clouds. There could be heavy turbulence in them. Can you sit on the clouds or surf on them as you would do on snow or in water? You can't, because clouds are made of water vapor, which is the gaseous state of water. Gases do not have definite shapes or volumes. This lesson is about the states of matter and how matter is composed of particles whose behavior determines the states of matter. On completion of this lesson, you will be able to define the word matter, list the properties of solids, liquids, and gases, list the attributes of the particles of matter, and explain the three states of matter in terms of the attributes of the particles of matter. Before we move on, let's look at the properties of solids, liquids, and gases. Solids. Solids have definite shape and volume. Cannot be compressed, except porous solids. Particles do not flow. Diffuse slowly. High force of attraction between particles. Very less intermolecular space. Liquids. Liquids take the shape of the container and have definite volume. Cannot be compressed. Particles flow. Diffuse fast. Less force of attraction between particles. More intermolecular space. Gases. Gases have no definite shape and volume. Can be compressed easily. Particles flow easily. Diffuse very fast. Very less force of attraction between particles. Large intermolecular forces. Why does matter exist in the form of solids, liquids, and gases?
What is matter?
Matter is any substance that has mass and occupies space. All physical objects are composed of matter.
So, is matter made up of something?
Yes, matter is made up of small particles.
Is this grain of sand a particle that you're talking about?
No, that grain can be further broken into smaller particles, which are not visible to the naked eye. Those are the particles I'm talking about, and they explain why matter exists in the form of solids, liquids, and gases. Particles in matter are in a constant state of random motion, and hence they possess kinetic energy. They also attract each other, but this mutual force of attraction is effective only when the particles are very close to each other. When the particles are bound together firmly, as you can see here, they form solids. In solids, the particles simply vibrate about their fixed positions, because their kinetic energy is low and not enough to let them break away from their mutual force of attraction. Therefore, solids have definite shapes and volumes. For the same reason, they do not flow or diffuse. In liquids, the kinetic energies of the particles are more than in solids, and the particles are not bound to any fixed positions. They move around freely, at random, throughout the liquid. However, they do not have enough kinetic energy to break out of the boundary of the liquid mass. That explains why liquids do not have definite shapes and flow or diffuse freely, but they do have definite volumes. Also, compared to solids, there are more spaces between the particles of liquids, but not enough to make liquids compressible. In gases, the particles are not packed together at all, because their kinetic energies are high enough to let them break away from any boundaries. They are free to move around in random motion. That is why gases have no definite shape or volume, and they flow and diffuse easily. They collide with each other and with the walls of their container. That's how a gas exerts pressure on its container. Also, because the spaces between the particles are large, gases are highly compressible.
Now I understand. Just let me summarize what you said. Solids. Solids have definite shape and volume, cannot be compressed except porous solids. Particles do not flow, diffuse slowly, high force of attraction between particles, very less intermolecular space. Liquids. Liquids take the shape of the container and have definite volume, cannot be compressed, particles flow, diffuse fast, less force of attraction between particles, more intermolecular space. Gases. Gases have no definite shape and volume, can be compressed easily, particles flow easily, diffuse very fast, very less force of attraction between particles, large intermolecular space.
It's a warm, sunny day. The icebergs have started to melt.
Water becomes solid at very low temperatures. Ice melts and changes back to water when the temperature increases. This phenomenon of matter converting from one state to another is known as interconversion of the states of matter. In this lesson, you will learn about the interconversion of the states of matter. You will also learn about the effect of temperature and pressure on gases. At the end of this lesson, you will be able to explain how temperature affects the three states of matter, explain the concept of latent heat, list the factors that cause evaporation, explain the cooling effect of evaporation, explain the concept of condensation, and describe the concept of sublimation through an experiment.
I don't understand. Why does ice melt on a sunny day?
To understand the melting of ice, let's perform an experiment. Take about 150 grams of crushed ice in a beaker and place it on a tripod. Next, suspend a laboratory thermometer into the ice in the beaker. Then, heat the beaker with a Bunsen burner. Remember to note down the reading of the thermometer every half minute. Observe that the temperature shown by the thermometer remains at 0 degrees centigrade till all the ice melts. After that, the thermometer shows a rise in temperature.
Why is that?
Heat energy is used up in changing the state of matter. In our experiment, the heat is used to increase the kinetic energy of the particles of ice to such an extent that they break away from the rigid lattice structure of the solid form, ice, and move around freely to form the liquid form, water. So, until all the ice has melted, the heat absorbed does not raise the temperature of the ice-water mixture. This heat, which does not raise the temperature of the body, is called latent heat. The latent heat of fusion for any substance is the amount of heat energy required to change 1 kilogram of the substance from its solid state to its liquid state at the same temperature. Getting back to our experiment, Let's continue to heat the water and note down the thermometer reading every minute. Observe that the water has started to boil and steam is rising from its surface. Also notice that the temperature has stopped rising. It is now steady at 100 degrees Celsius.
Amazing! Why does the temperature not rise further?
Water boils at 100 degrees Celsius. At that temperature, it changes from the liquid state to the gaseous state. Just like in the case of ice turning to water, this change of state also requires latent heat. When 1 kilogram of a substance in the liquid state changes into its gaseous state at the same temperature and at standard atmospheric pressure, the heat energy used up is known as the latent heat of vaporization of that substance.
Ah, I see. Every time matter changes state, latent heat is taken in or given out. But do we really need to heat things to change them from one state to another?
Not necessarily. For example, seawater absorbs the heat from the surroundings and vaporizes, leaving behind the salt that was dissolved in it. This process is known as evaporation. Thus, a process where a liquid changes into vapor at any temperature below its boiling point is called evaporation. Evaporation occurs only at the surface of the liquid.
Interesting. Tell me more.
Shallow quarries or bunds are built near the sea. The shallow bunds provide a relatively large surface area for water to evaporate quickly, much like the clothes that you spread out on a clothesline so they dry faster. Water from these bunds evaporates, leaving salt behind. Then the salt is collected and refined before use.
So, the rate of evaporation depends on the surface area. What else does the rate of evaporation depend on?
Well, evaporation also depends on the temperature of the surroundings. You know that the clothes dry faster on a sunny day than on a cloudy day. Thus, evaporation is faster at higher temperatures. You're probably thinking that clothes also dry quicker on a windy day. You're right. This is because of the speed of wind. The particles of water move quickly, reducing the amount of water vapor in the surroundings. You know that water evaporates, but what happens after evaporation?
The water vapor condenses and we receive the same water in the form of rain.
Yes, let's study this phenomenon with an example, which is very common in our everyday life. Let's take an ice-cold water bottle. Leave it on the table for 2 minutes. Observe water droplets on the outer surface of the bottle. These water droplets are condensed water vapor present in the air around the cold bottle. The process where a vapor changes to liquid is called condensation.
Can I convert this liquid into a solid?
Of course you can. Watch this. I'm going to place the same water bottle in the freezer and remove it after a few hours. See, the water in the bottle has frozen. A liquid converts into a solid when the temperature is lowered below its melting or freezing point. The process where a liquid converts into a solid is called freezing. Sometimes, a solid directly converts into a gas while heating, without changing into liquid. Let's do an experiment. Take a few ammonium chloride crystals in a china dish. cover the china dish with an inverted funnel. Then, plug the open end of the funnel with cotton. Slowly heat the ammonium chloride crystals in the china dish. Observe that the solid crystals of ammonium chloride directly change into vapor without changing into liquid. Now stop heating. You can see the vapors of ammonium chloride settle as crystals on the inner walls of the stem of the funnel. The ammonium chloride crystals can be collected from the inner walls of the funnel. The process where a solid on heating directly changes into gas without changing into liquid, and a gas on cooling directly changes to solid without changing into liquid, is called sublimation. Now, let us see the effect of pressure on the interconversion of the states of matter. You know that gas gushes out with a hissing sound when you open the knob of a domestic gas cylinder. In a domestic cylinder, the gas is compressed at a high pressure and a low temperature and is stored in the form of liquid petroleum gas. When the knob is opened, the pressure is released and the gas gushes out. However, this is possible only in gases because gases can be compressed. Gases can be liquefied by increasing pressure and lowering temperature. This principle is used in the liquefaction of air to separate the components of air. To sum it up, the process where matter changes from one state to another and back to its original state by altering the temperature is interconversion of the states of matter.